Graph the parabola from the given equation. We have the square of x plus 1 equals 1/4 times the quantity y minus 3. This is a very useful form for the equation of a parabola for graphing, which we have not learned about yet. This is often referred to as the standard form for the equation of a parabola. However, our textbook refers to the forms below in bold as the standard form for the equation of a parabola, which is more commonly referred to as the vertex form for the equation of a parabola. We'll be using the vertex form for the equation of a parabola to make the graph. Because the x part is being squared, we will solve the equation for y and write the equation in the form of y equals a times the square of x minus h plus k. To begin, we want to eliminate the 1/4 on the right side of the equation. To do this, we'll multiply both sides by 4, which gives us 4 times the square of x plus 1 equals 4 times 1/4 times the quantity y minus 3. Simplifying on the right side, 4 times 1/4 simplifies to 1. Let's also reverse the order of the equation and now write the equation as y minus 3 equals 4 times the square of x plus 1. And now we will add 3 to both sides to solve for y, giving us y equals 4 times the square of x plus 1 plus 3. Now that we have the equation in vertex form, again, notice because the x part is being squared, the parabola has a vertical axis of symmetry, which indicates the parabola opens up or down, and because a is positive 4, we know the parabola opens up and will resemble this shape. Notice the parabola does have a vertical axis of symmetry. The vertex is always the point h comma k, so let's determine the vertex. Because we have x plus 1 and we identify the value of h in the form of x minus h, h is negative 1. X plus 1 is equivalent to x minus negative 1. And because we have plus 3 on the end, k is positive 3. We now know the vertex is the point negative 1 comma 3. Let's plot the point on the coordinate plane. This is the vertex. Let's also sketch the axis of symmetry, which is this vertical line passing through the vertex. And now let's find some additional points on the parabola using a table of values. When completing a table of values, we do want to be strategic about the x or y values we select to avoid fractions, which won't be an issue with the given equation. Let's begin by selecting x equals 0, which will give us the vertical or y-intercept. Performing substitution when x equals 0, we have y equals 4 times the square of 0 plus 1, or the square of 1 plus 3. Simplifying, we have y equals 4 plus 3, or 7. We now know the parabola has a vertical or y-intercept of 0, 7. Let's go ahead and plot that point, which would be here. And because we have the axis of symmetry, we know there's a mirror image of this point on the other side of the axis of symmetry, which would be this point here, the point negative 2, 7. And now we already have enough information to make a nice accurate graph of the parabola passing through the 3 points. The parabola looks something like this. Let's verify this graph using Desmos.com. I've already set this up. Notice the parabola opens up. The axis of symmetry is the equation x equals 1. The vertex is negative 1, 3. The parabola also passes through 0, 7, as well as negative 2, 7, verifying our work is correct. I hope you found this helpful.